Hi everyone, it's Dr. Adams, and I want to talk to you today about an important concept, and that is that the atmosphere is a three-dimensional feature that's often rendered two-dimensional in your textbook when you look at diagrams and charts and so on. And I just want to give you an idea of how you can take some of those two-dimensional images and then start to think about them in a 3D fashion. And in particular, when we talk about the standard pressure levels, when we look at those charts when they come in, sometimes students have difficulty finding ways to figure out how does that actually look in the real world, so to speak. So I'm going to do my best today. I apologize in advance to sort of sketch this out. What you'll see on the screen here is a 500 millibar chart. And what this is depicting is the pressure where we find 500 millibars in the atmosphere above the Earth's surface, and at what level, at what distance in the atmosphere, the height in the atmosphere do we find that. And the flat image shows us that, but then it does actually have a 3D sort of component to it. So what we will do is first, when I look at the image, I notice that there is a ridge that sort of pushes northward towards the Rockies. And then we have a trough that swings through the southeastern United States. And so that might look something like this. When I sketch this for you, there is my ridge and there is a trough. Okay, so as a starting point. The next thing that we'll do is we need to indicate that this is some height above the surface of the Earth. And then therefore, and as we go towards the north, then we'll notice that that pressure level decreases. So here we have the south, and here we have the north. And again, this is just a cross-section, a sample that we're doing. And so we'll know that if this is the top here, where we find that first contour, which is 5,820 meters, then over time, this pressure level is going to decrease as you get towards the north. So in our first instance, we said that that first contour is 5,820 meters. So this is the distance where we find 500 millibars at this particular location above the surface of the Earth. You'll notice that the subsequent contours, or isoheights, they also mimic this because there is a pattern here. And so the difference between these is that the next contour is found at 5,760 meters. Okay, and so the difference between each of these contours is 60 meters. We go to the next contour, and again, following that same pattern. Okay, in this case, the distance is going to be 5,700 meters. And then the third one that we'll work off of today is the last one, which is 5,640. And again, it's following that same pattern. So this is 5,640 meters. And there is one behind that, which is the 5,580. Okay. And we can put that in 5,580 meters. And then I can close or connect all of these to begin to create that 3D image that I'm looking for. And we don't want that one, I apologize. We're going to get this connected over here. And this is where, again, I'm not the world's greatest artist. So we'll try to create that for you. So hopefully, in some essence, you can see that each of these lines represents 500 millibars. This is where we find this pressure level in the atmosphere. But you'll notice that as you get further north, that these lines, these pressure lines, become closer to the surface of the Earth, whereas when you're in the closer to the equator, we find them higher above the surface of the Earth. So there is a three-dimensional component here to the atmosphere and what it looks like. And so that, I hope, gives you an idea as how you can visualize two-dimensional charts and images in a three-dimensional fashion.